Good evening, everyone. My name is Randy Baldwin. I'm the Vice Chair of the Manitoba Sustainable Energy Association. We'll get going now. Welcome to all our audience members. MANSEA, or the Manitoba Sustainable Energy Association, is a promoter of renewable and sustainable energy in the province of Manitoba, made up of a small group of dedicated volunteers. And we first got together in 2005. We're always looking for new directors, so if this is something that's of interest to you, please don't hesitate to contact myself or Wayne Digby or Wayne Clayton. They're also involved in MANSEA and have been for many years. You can learn more about MANSEA by going to mansea.org, our website, and to learn more about us, just click on More and then About Us. That's the website where you went to register to attend these conferences sessions. MANSEA works closely with other like-minded associations and groups, including the Manitoba Environmental Industries Association, Manitoba Electric Vehicles Association, Manitoba Geothermal Alliance, and Sustainable Buildings Manitoba. We'd like to acknowledge MIA's involvement with MANSEA as a supporting partner. MIA's working relationship with MANSEA has been strengthened during the past year through a partnership that we developed to deliver a number of webinars this summer and fall, and then they're significantly assisting us now with these conference sessions. Sarah Neal is MIA's office and finance administrator, and she's our webmaster behind the scene, making sure that everything runs smoothly tonight. Jack Winram, who you'll meet in just a few minutes, is MIA's executive director. He's a member of the MANSEA board and will join us, as I said, a little later to moderate the question and answer sessions. And there'll be one of those after each presentation. In addition to our supporting sponsor, MIA, we want to thank our platinum sponsors, Evolve Green and Golden West Communications, and our gold sponsors, Access Credit Union, Efficiency Manitoba, and PolarTech Solar. We'd also like to acknowledge that Access Credit Union is our sponsor of this evening's presentations. Audience members will find that it's best to use the side-by-side viewing setting, and you'll find that up in the right or up top corner of your screen if you want to change your setting. And before we introduce our speakers this evening, I just want to take a minute to acknowledge that our meeting is taking place from Treaty 1 territory, and that this is the area of the traditional territory of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and the homeland of the Métis Nation. Our topics this evening are all things related to biomass. Biomass can be a great source of heat for grain drying or heating buildings. We had planned this evening to also have Clint Pinder from Firewood, Manitoba join us as our third presenter, but he was unable to join us because of a family commitment, and we wish him all the best in dealing with an ailing parent. That's the reason why he couldn't be with us this evening. There'll be time for Q&A, as I mentioned, following each presentation, and then a short open forum at the end of the evening. We're planning to disable the chat function as soon as the presentations start. So if you want to submit questions at any time as they come to mind, please do so using the Q&A function that you find at the bottom of your screen. We'll do our best to answer all your questions this evening. I'd now like to introduce Cam Cornelsen from Triple Green Products. Cam will speak for 30 to 40 minutes, and he is the co-owner of Triple Green Products, as well as the co-founder of Norstar Industries at Rosenard. Cam firmly believes there are solutions that are more cost efficient than traditional energy sources and that don't wreak havoc with the environment. These solutions deal with existing waste problems in a responsible fashion. They're carbon neutral, thus saving on ever-increasing carbon taxes. Many of these solutions have been around for a long time, but in recent years, they've been refined, and now are accessible to all industries and are being applied in innovative ways. And it's time to make these more mainstream. CAM's presentation, A Solution to Many of Our Challenges, will focus on the use of biomass feedstocks to generate heat for grain drying and space heating for a whole wide range of buildings, including hospitals, central district heating systems, greenhouses, agriculture, and other buildings. CAM will describe how biomass energy systems can save farmers money and reduce our carbon footprint. Once again, audience members, please submit your questions using the Q&A function. And Cam, if you can please take it away and share your screen.
Good evening. My name is Cornelsen, and I'm here to present to you a better way from Triple Green Products. Triple Green Products is part of a Norstar group of companies. Triple Green Products manufactures and installs industry-leading equipment into agricultural, institutional, municipal, commercial, and industrial sectors, focusing on sustainable biomass fuel, renewable energy, and environmental conscious handling and recycling of organic waste materials. We have built a reputation for supplying proven, long-lasting solutions. One of our core products is the Triple Green Flame heating systems that utilize various biomass materials as fuel for combustion to generate heat energy. Biomass material is organic matter that can be used as fuel, and when it's released in a controlled way, this energy is used to heat communities, commercial buildings, hospitals, food processing plants, large farming and greenhouse operations. Biomass fuel furnaces can be used with burning wood chips, pellets, compost, and many hard to burn solid agricultural residues. Triple Green Energy will help connect you with your best local sources for solid fuel needs, and the availability of solid fuels is becoming increasingly easy to get as a result of population growth and waste that is created from wood. Triple Green Flame heating systems is a biomass. Just a minute, there we go. Energy costs are currently a significant line item for any enterprise and are going to continue to rise as fossil fuel choices become more volatile and controversial. Carbon impact, carbon tax, carbon regulations are current realities. Sustainable biomass fueled heating is carbon neutral. Environmental consciousness is marketable, and we all want to be green. Our mission is to remain North America's leading clean and renewable energy provider by manufacturing and distributing the most reliable, efficient, and carbon neutral clean energy products on the market. We are committed to social responsibility and provide cutting-edge renewable energy solutions that utilize solid biofuels to provide heat, steam, and optionally electricity at a fraction of the current industry's costs. Triple Green Product solutions are unique in that we have been the industry standard for long-lasting reliability, providing clean energy solutions and cost savings for over 25 years. We are committed to ensure our clients have reliable equipment and energy sources now and into the future. Triple Green Products are backed by a highly qualified and competent team. Triple Green Flame heating systems utilize biomass fuel combustion to generate heat energy. Systems are available in 3 models: hot water, steam, and forced air, with capacities between 250,000 and 35 million BTUs. The hot water system uses biofuel combustion. Steam systems can be used to produce higher temperatures and as a result suit different applications. Forced air systems offer a unique advantage for specific applications. This system provides hot, dry forced air in environments where higher moisture levels may be present. Here's a slide. It's just an example of what one of these units would look like when we're using them to use hot forced air. In our systems, when we get to a site and we set it up, the one end of this unit would be fuel fed, which is a U trough with some plating in it, and it would be bringing in the fuel source. And then on the other end of that same unit is where the exhaust would be coming through, or the hot air that we're capturing. And there's a dust collector on that collecting any of the impurities that would fall away. And then the last slide here is just a picture of the flame within the stoker. These units come with automated ash removers, which is something we'll talk about in a little bit. There's a soot blaster, multi-screw fuel feeding systems, fire suppression system, combustion fans, fire suppression controls, and of course the fuel hopper. So this is just kind of a cross section giving you a quick overview of what a typical system might look like. The benefits of a boiler is that our models are turnkey and they're able to integrate with existing heat systems. Furnaces can be installed inside an existing mechanical room and operate out of sight with minimal noise. Our systems feature unique benefits such as high efficiency biomass combustion, fully automated ignition. It's compatible with existing central heat systems, fully automated control system with touch screen monitors, smartphone connectivity, automatic ash removal system, automatic feed, and of course the cyclone filter and collector system. This is just a cross-section elevation, again, giving you a sense of what this product could look like and its ability to fit within current systems. Here's a close shot of the combustion chamber. So it features a complete fuel air combustion control, hold fire ability to prevent combustion cycling, O2 trimming, complete combustion with best in industry emissions, and reduce or eliminate buffer tank requirements. Integrated solutions that come along with this is a walking floor for fuel delivery, which provides constant, reliable method of feeding solid chip fuels to the boiler or furnace. It's fully automated, robust in manufacture, so it's going to be long lasting, and multiple sizing. We also work with providing pellet silos, fuel feeding hoppers offered in multiple sizes, automatic ash removal, multi-cyclone filter, and the cyclonic bag filter system. So again, just a quick overview from looking at the pictures from left to right. The walking floor is just literally that. There's a chain with grates in it that move back and forth, pulling the product back into the feeding system, which is typically going to be a screw conveyance that moves the product up into the stoker, and of course providing the heat for the boiler. You see the burner chamber and the dust collector. All of our products are controlled. We've got a control panel that's very elaborate and well planned out, and we have a touchstone screen that allows us access to the control of the product and the many variables that go into it. Again, a close-up of the touchstone spring, and also we're able to see our fuel usage, and we can monitor and calibrate our fuel as it's going through the unit. Also consider our direct fire dryer systems. With well over 10 years of biomass direct systems in operation and drying and dehydrating applications. Watch out for our newest model, which will be unveiled in summer 2020. That's really a typo. We will be and are unveiling in 2021 our grain drying system. And so we're a little further along than the slide presents. For the best effective solutions in grain drying and mining operations, and we'll talk about that in a bit. To connect with our bio dryer systems for dehydrating all types of organic waste, producing ingredients for organic types of fertilizer. Again, that's something that we're just coming through our beta testing and we're quite excited about. We have been set up in mines for many years where our product has been used for drying raw gypsum and limestone. Municipalities can use our recycling of waste to energy and we are able to dry and dehydrate products. So when we talk to about gypsum mining, and we'll just spend a little time here because this is a precursor of experience of what we've used in products that we're moving forward with now. Triple Green Products has biomass dryers that have been in mining operations for over 10 years. A big part of that is removing the crystalline water in the calcination process of dehydrating gypsum into plaster and stucco. Production and calcination use significant amounts of natural gas typically and are fossil-derived electricity. And so again, with this, we are just a much better, greener and more cost-effective solution. Just a quick snapshot of a mine use where we have got a bio dryer drum currently being used with a collector bag house for the exhaust that's coming through, and of course the direct fire system. Triple Green products have been in the mines for 10 years, and we supply up to 33 million BTUs on our units and can be coupled to produce much more heat as it is needed. Really important to remember that this heat is a dry heat, and so it's much more efficient and takes less fuel compared to propane or natural gas, which actually create moisture in their process. This leads to significant cost savings, and of course it's carbon neutral, reducing carbon tax on gypsum and calcination processes. Our filtering system, which I alluded to earlier, has been installed in many types of operations, from institutions to ag operations. This operation helps take our biomass system to the next level because we are meeting most air emission standards. Our cyclonic filter system is our newest innovation in our line of products. This filtration system takes to a new level. Through this new technology, we are able to break into markets where there have been no solutions to environmental problems until now. With this system hooked up to our biomass boiler, we're able to solve long-standing problems where, for example, in ag waste, there have been no good options. And so again, this solution can be incorporated at the farm level. Poultry litter does not have to be transported off the farm. And there's a long side track that I could go on just explaining that, but that is a really, really big deal. And again, the boiler forced air furnace generates heat to the barns while burning off the chicken litter. So there's a double benefit there. Residue from this burn also is an ash that is entirely made up of KCLs, and those can be captured and used on crops as the highest form of fertilizer. And just to give you an idea of value of and potential value of this, in 2012, 233,000 plus poultry farms were registered in the United States. A result of that is 5.7 billion pounds of poultry litter produced each year. This is all fuel for our biomass systems. Significant effects on the land and the air quality of the surrounding areas is always a challenge, and no easy disposal solutions. Up until recently, and because of our filtration system, burning was not an option. I've got a slide here that I would like to show you that gives us a good overview of the barn application.
Triple Green Products introduces the first fully integrated chicken litter waste to heat system for poultry farmers. The cycle begins with your between flock cleanout. The chicken litter, now your fuel, simply needs to be moved out of the barns and into a space where it'll be kept dry until it is moved into the fuel feed hopper. Triple Green Products offers various fuel handling options based on your desired capacity. Here you see a walking floor fuel hopper with a roll tarp to keep the fuel dry. The amount of fuel in the hopper can heat a chicken house for several weeks or longer, dependent on size and overall temperatures. The furnace exhaust is forced through the Triple Green's cyclonic filtration system, our patent-pending filtering system that will remove the smallest of air contaminants previously associated with burning chicken litter. Triple Green's forced air furnaces connect to the easily installed duct system to introduce the heated air into the chicken houses. The forced air or boiler systems are available in the BTU scale you require, based on the size of your operation. With heating costs reduced by as much as 80%, you'll see a full return on investment in 2 to 5 years, depending on the size of unit you implement. The residue of the filtered burn, the KCl fertilizer, is loaded into large pallet-sized tote bags from the cyclonic filter. This byproduct is premium fertilizer that can be sold or used on your own fields with no environmental concerns about runoff. Triple Green's dehydrator is the perfect option to turn mortalities into heating fuel in as little as 24 hours. It uses the heat from the furnace exhaust stack to dehydrate the mortalities efficiently without additional operational costs. The dehydrated fuel is then unloaded through an auger into a tip dumpster so it can easily be added to the fuel feed hopper. Our heating systems offer hot, dry air, which reduces moisture, lowers ammonia levels, significantly reduces heating costs, and reduces mortalities by up to 50%. Our forced air and boiler systems have been successfully burning chicken waste for more than 10 years. Now, with the addition of our patent-pending cyclonic filtration system, you can safely use your chicken litter as a source of heat with no contaminants such as KCLs and meeting all North American, regional, and federal emission standards. Let one of our product specialists or dealers answer any questions you may have. Triple Green Products, a better way.
Just kind of putting a cap to that presentation. In the Chesapeake area alone, there's 32,340 poultry farms. And so the need, the demand is large. And certainly that has been an incentive for us to pursue this opportunity. We're very excited at this point to be talking about grain drying. We did our beta testing on this last fall. We've been working on tweaking some of our challenges that came out of that testing. And this is a product that we're looking to take to market publicly here in the next couple of weeks. And again, to kind of getting a background of the need for this, more than 900 million acres of land in the Midwest United States is planted to corn. And in 2019, total Canadian corn acreage for grain was expected to come in at 3.7 million acres. Drying grain has become one of the most energy intensive operations on the farm. It's a significant cost to farming operations and in many cases is subject to carbon tax. Triple Green Products solution to the costly operation of drying grain uses commonly found fuel such as corn stover or other forms of fuel found on a typical grain farm. Again, the dry heat is a really big deal because of the efficiencies that it brings relative to traditional carbon-based fuels. It's a significant cost savings to farm operations, and because it's carbon neutral, it eliminates the carbon taxes on grain drying operations. Here we're picturing a typical 10 million BTU system that we were using for our testing and what we are looking to come to market with. Here's just some pictures, candid shots of our beta testing on a number of units that we did our testing on, just to show that we're designing these things in such a way that they're virtually a plug and play application, easily adaptable to existing units. We did a case study of a farmer in mid-North Saskatchewan. He's cropping just over 9,000 acres, and he's harvesting annually well over 500,000 bushels. It's a mixed farm of wheat, oats, canola, and corn. And in this case study, we used an eco-dryer model 24210 that requires 17,400,000 BTUs per hour. And we're drying down all of these products 5% moisture points. If we were to look at traditional ways of drying this, and we're looking at carbon fuels such as propane or natural gas, you can look at in this graph in the year 2021, if you were to use propane to dry all of that product down, you would spend $194,000 on propane alone. And the carbon tax this year would be $18,000. So that farmer is looking at probably about $210,000. It's a really, really big price tag. If he were to use natural gas, in his area, natural gas is less money. He would be looking to spend $72,000 with a carbon tax hit of $15,500. All pretty significant numbers and a hit to his operation. When you prorate and look forward to where those costs will migrate in 10 years from now, by the year 2030, the propane cost is going to run him $232,000 with a $78,000 carbon tax. So he will be looking at well over $300,000 to drive the same amount of product, the same amount down. If he's staying with the natural gas, his costs are significantly less at $86,000, but the carbon tax would be coming in at almost $66,000. So again, coming in around $150,000. It's a significant hit to his operation. Carbon tax rates we just took off of what had been produced by the federal government. So this is their chart that we were using. This graph much better identifies the value of biomass heating or a corn stover as a fuel source, using the same numbers as I just went through previously. This year, if we just looked at the natural gas because in his application, propane is just not really a viable operation or option. So natural gas, where we were to combine the natural gas and carbon tax, again, around that $87,000, $88,000. Corn stover, and really corn stover would have no cost other than harvesting it from the field and bringing it to the yard to be used. We would see that coming in at a cost of just over $8,000. If we jump forward 10 years from now, you can see that the natural gas increased cost is incremental, and we don't know exactly. So we created a conservative but realistic expectation of where that would land at $86,000. The carbon tax, as prescribed by the federal government, would come in at a cost of $65,900. So again, about a cost of $150,000. When you look at the corn stover fuel cost for biomass in the next 10 years, you would see an increase of roughly $1,600. And that speaks to an ongoing savings year over year, and certainly to the return on investment. Not to mention again that we're green. Just a quick slide to show you that there's other fuel sources that come off of the farm that are beyond corn stover. If you're able to gather canola straw, that is going to be even more cost effective than corn stover. A little harder to bring off the field, but is done. And then wood chips is more an off farm option that is available and you can get, or coming back to an oat pellet. But again, different fuel sources that all would work with the biomass system, and all greatly savings as composed to traditional carbon fuel. We also have other products that we are providing and building, and we're excited about: composters and dehydrators. And these provide environmentally friendly solutions to food and restaurant industry, livestock producers, processors, cannabis growers, and greenhouses. And these are industries that have reached out to us, and either we already are working with or are in the process of developing products for them. It's a hassle-free way of dealing with waste. You can load food, manure, mortality, plant waste into a vessel, and combining with a bulking agent such as wood shavings or a natural aerobic processing into a compost fertilizer material, or without a bulking agent and dehydrate it into a reduced volume biosafe material. When we dehydrate it, we find that becomes a really good fuel source for our furnaces. These models range anywhere from 6 feet to 75 feet long. More products that Triple Green Products make available, again, are containerized walking floors. auger V-bin biomass feed systems for plug and play and portable setups, material handling U-troughs and belt conveyors. We have slow speed grinders and shredders to break up the waste to make it easier for the ovens to process. We've got hot water buffer tolerers, and we do build customized solutions. Triple Green products have solutions for challenges that have been accepted as a cost of doing business for way too long. We want to challenge the playing field. We want to give businesses the opportunity to redirect their finite dollars back into job creation, research, innovation, and value for future generations. The solution is a state-of-the-art carbon natural furnace with boiler systems that utilize solid biofuels to provide heat, steam, and optionally electricity at a fraction of the current fossil fuel costs. Significantly reduce energy costs realized immediately, netting increased profits and cost savings. We want to reduce carbon profile significantly with carbon neutral heating system, reaping benefits from a tax standpoint and garnering a reputation for commitment to a greener environment. To implement without rebuilding your existing infrastructure. We feel we have a better way. We want you to enjoy fuel cost savings from 30 to 80% with sustainable, increasingly abundant biomass fuel sources, a carbon neutral heating solution that is environmentally friendly. And that is marketable as everyone wants to be green, triple green. Thank you.
Sorry, it just took me a minute to find my unmute switch in my camera. That was a great presentation, Cam. You went through a lot of information in a hurry there. I'd like to introduce Jack Winram. As I mentioned earlier, Jack is the Executive Director with the Manitoba Environmental Industries Association, a role that he's been in for just over a year now. Jack brings a wide-ranging background from industry, from the regulatory environment, and from government. Jack, please take it away for the question and answer session.
Thanks, Randy, and thank you for the opportunity to participate in your conference. This is the second night of the three-night conference, so appreciate that. And of course, if I might say, I think this is one of the success stories of this pandemic year. There's of course been a lot of hardship, and some people and organizations and businesses have been hurt. But I think one success story we can talk about is the relationship between MIA and Mancia. It's been a great collaborative effort by both parties. So looking forward to that in the future as well. We've got a lot of questions coming in, and I know we've got a time limit. So I'm going to get right at it because there's some really good ones here. So starting with Merv Starzik, he's got a question about are there any boiler furnace units operational in Manitoba? And I'll just expand on that a little bit. Of the different technologies that you spoke about today, Cam, what do you have in operation or in pilot or demonstration in Manitoba? You mentioned a mining application, but of the other technologies, what do you have going?
So just a little bit of background really quickly is that my partners and I bought a company that had been in business for well over 10 years, and just over 2 years ago, we're into our third year now. And so that company that we bought had products out there. So yes, mining in a couple of greenhouses that we're aware of in southern Manitoba. And we've also been involved in our beta testing with our grain dryers. We did one in the Portage area last fall. And then now, again, this spring, we've been working through that. And we've sold a few now in the Morse area. And actually just today, we sold another one into Ontario. But beyond that, we also have units all over Ontario and Quebec. And right now, we're also installing a unit into a hospital in New Brunswick. So there is a proven track record, and we're certainly open to touring people through these operations if they have an interest in seeing them.
I would imagine you'd also assist them with, you know, taking a look at the economics of whatever application they might have in mind. Is that something that you go through with potential customers?
Absolutely. I mean, those kind of questions we're used to getting. I will very quickly state that I am not the CEO of this company, and so I don't do the day-to-day things. But we do have people in place that know these the systems well, more adept at the selling of the features and the benefits, and also the locations.
So next question is from Clinton Pam Cavers. How much backup power would be required to keep a system like this firing in the event of power outage, a backup power? I think this question was put during when you were showing your large furnace stokers near the beginning.
You know, I'm going to have to defer, and I apologize. I don't know that per se. I do know that there's a certain amount of automation and backup built in to allow for that. I'm sorry, I technically I don't have a quick answer for that.
Yeah, no worries. The next question has to do with the emissions and the environmental side of it, and the concept of your technology being carbon neutral. Do you have some sort of a carbon scrubber or chemical process to remove carbon from your flue gases?
So we do have a filtering system that we had tested just this winter by the University of Virginia, and that filtering system, I don't believe that there's a scrubber in there, but there is a system in there that it's a filter that I know that is removable, and they clean it as prescribed. And we're told that it did pass all of the testing.
Next question is from Brent Weary. Can one of these biomass generators be adapted for human waste, for example? I'll just add to that, maybe hog waste, other agriculture type waste that you didn't already mention. Has that been done in Canada before?
So I know that we've handled waste. We've handled animal manure for sure. I don't think there would be any issue with human waste. The question or the variable that would have to be dealt with would be moisture content. That would be the biggest challenge that we would need to deal with. And there are ways to manage that.
Next question is from Wayne Digby. Within the Canadian context, and more specifically Manitoba, what are the main stumbling blocks as far as your technology being more accepted and utilized, and what needs to be done in order to overcome some of those stumbling blocks?
So I think a big part of the stumbling blocks is perception. You know, we've always traditionally handled these challenges with carbon products, and so that's the way we've always done it. And one of the questions that comes up very quickly is fuel sources. You know, we don't want to cut down any more trees, and there's a perception that that is going to be the shortfall, that at some point we'll run out of fuel. When we work with municipalities, we've become aware that there's a growing problem in waste yards where people are taking burnable products, wood, cardboard, all these things, and they're starting to take over these nuisance grounds, and municipalities are looking for a place to get it. And we're seeing it as we add more and more. As populations grow, there's more and more waste that is truly burnable and easily shredded and to become a fuel source. But there is a perception that there's a limitation on fuel sourcing. And I think education is going to be a big part of it. And as we get the early adapters starting to see it and seeing it, the value and the return, I believe that we'll get through that.
Yeah, I was wondering if one of the stumbling blocks, or if you cared to comment on the regulatory side of things in terms of getting the technology approved here in Manitoba. But that's a good segue into the next question from Wayne Clayton, which is also regulatory related. Has the use of chicken litter in the burn units passed Manitoba conservation standards, or are there emission tests required at each place this is set up? So an overall regulatory question on terms of getting permission to set one of these up.
So we're having the University of Manitoba doing some testing right now. And we're doing that through the confidence and green light, if you will, that we've gotten through the University of Virginia. And so we want to be proactive with that and be ahead of the curve. And certainly our hope is that if we can get a white paper from the University of Manitoba, and again, that is our expectation that we will, that we can provide some comfort at the provincial level so that we can get that passed for provincial passing.
Yeah, so another question on the carbon neutrality of the technology. Are the emissions lower than natural gas?
That is my understanding.
With municipal waste, sorry, next question from Wayne Digby again. With municipal waste, that what elements are you able to utilize in your systems? For example, an average landfill site, what can you use?
So I'll just go back to the experience we had. We're in the RM of Morse, and so we've been working with them, and we're seeing a tremendous amount of pellets that could take in and just get dumped because they don't have a use for that. So that's a real natural, real quick one that we can go to. You see there's a lot of construction going on, and so wood wastes that come off of renovations, cutoffs, construction site type units, those are the easiest ones that we go on. We're seeing that at a lot of these waste sites, they're getting more careful with what's being delivered, and they're being dumped into designated areas. So for example, cardboards, paper products, those kind of things are a lot easier to harvest out of these sites. And so those are the easiest targets that we would go off.
Again, one of the stumbling blocks, might be just connecting the supply chain of feedstock. So the next question is from an anonymous attendee. How do we match biomass producers with biomass users?
I'm sorry, repeat that?
How do we match biomass producers with biomass users? So if you were to purchase and set up and make one of these units operational, where are they going to get their biomass from? What supplier or what producers are out there that they can tap into?
So we recognize that that's a challenge, and that is a really good question. There are more producers than we had first expected, and so we are aware of people, and as a company, we would work with our end users to help them source those and find them. I mean, on a farm, a lot of those fuel stops are on the field, and so it's a matter of just bailing it, right? But in a more urban situation, I mean, there are companies that do produce it and are willing to deliver. And so if we can help, make that connection, we're happy to do that.
Whether it's the stoker or the grain dryer, is the feedstock does it have to be processed into some sort of an aggregate or smaller pieces? Do you grind it up, or can you just shovel it in? So in a typical farm setting where you have a grain dryer and they have the access to the biomass, what sort of things might they have to do to the biomass just to get it into the operation of the system?
For the smoothest operation, it would be good to get it chopped up and put into bite-sized or smaller pieces. It just really speaks more to the flowability of the product to get it to transfer from where it is to go up in through the augers and into the oven. And so, yeah, if you were to bale it, you would chop up the bale. Wood chips, they already come pre-chipped. If we come back to the municipal situation, yeah, you would have to get grinders to grind the product up. Primarily, it is, again, more for the flowability of the product so that it can feed in evenly in a consistent manner. We talk about cereal grains, wheat stalks or barley stalks, and that doesn't flow well if it's long and slender. And so again, chop it up and then it's going to flow and it'll work much better.
Yeah, it's great. Steve asks, how much processing would municipal wood waste require to be used for heating?
Well, again, we looked at doing it here at our local site over here, and we looked at that and said, I think, I mean, you'd have to get a good sized wood chipper, but really you feed a good sized wood chipper and you would, I mean, it would be a question of just getting that thing loaded and keep pushing the product through. How much? It's really amazing how much heat you can get from a ton of chopped, chipped wood. It does last a long, long time. It's really hard to say, a ton will give you X amount of BTUs because there's so many variables, different types of wood and so on. So, I could kind of guess at different volumes, but the efficiencies are very impressive.
So I would think whether it be a farmer or some sort of industrial process that might be looking into your technology, again, you would work with them on a case-by-case basis. What would be their access to feedstock and the availability of feedstock for that particular application, and then finding ways to make that work.
Absolutely. It's a really good question, and it's a good one to anticipate for sure. But my experience in this business has been that once you kind of cross that bridge and you become comfortable with it, it's not as overwhelming as one might imagine.
Yeah, so Wayne Digby asks, is your company involved in research on dedicated energy crops, particularly suited to production in Manitoba?
So we've been getting involved with that, and as we grow, we're allocating, and it is within our business plan to be continuing to do that and to grow in that more and more. I often refer to our company as an upstart that, we're birthing a 10-year-old company. And so we're growing into it. We're seeing a tremendous an excitement and an adaption of interest to people in what we're doing. And so, we're kind of prioritizing what we're doing first, but is that a part of what we're doing and part of our future plan? Absolutely.
I see Randy's popped up, so that means I maybe have room for one more question here, and I'd like to just bring forward Janice's question because I'm interested in this one as well. And every time I talk to you, Cam, and we've talked a couple of times in the last, few months, I found out about another technology, and I wasn't aware of your BioRouter, or at least if you told me about it, I missed it. But with the BioRouter composter, how many tons of fuel per day or week does it need to operate efficiently?
So what's really cool about that one is, and we're running one right now where we have our furnace going, and we're using it to heat a large barn operation. But we're tapping off of some of the excess height, the heat that's coming off of there, and we're pushing that back into our decomposter. And so it's just really our fuel source is free because it's just excess coming off of our furnace. I believe that heat in there that's coming in there is coming in around that 230 to 250 degrees, and it's working wonderfully.
Very cool.
I hate to be the party pooper. It's great questions, and I know there's a bunch more you didn't get a chance to ask, Jack. We'll let Richard do his presentation, and then if we have time, we'll come back to some of those questions for Cam that we weren't able to ask right now. Hopefully we'll have a bit of time at the end. I'd like to introduce Richard Grosshans. Richard is a research scientist at the International Institute for Sustainable Development and is associated with the IISD Experimental Lakes area and the work related to that area. Richard is the bioeconomy lead at IISD's water program. For the past 15 years, Richard has led innovative applied research on integrated watersheds and renewable energy management, exploring biomass harvesting, remediation of phosphorus and contaminants, wetland restoration, water retention, and sustainable drainage. Dr. Grosshans' presentation, Clean Sustainable Biomass Energy through management of natural infrastructure, including water retention and remediation, will describe his experience with harvesting cattails as a biomass fuel source and as a way of removing nutrients from a wetland. And he'll provide an overview of some of the work that IISD colleagues have done in developing a bioeconomy atlas, a tool to detail types and quantities of local biomass resources in Manitoba, which was a partial answer to one of the previous questions that came up. And I'd like to remind the audience again to use the Q&A function, and as you think of questions, please type them in. Richard, you're ready to go. If you can unmute your mic and share your screen, please.
Great. Okay, can you hear me okay?
Yeah, you're good.
Okay. Can you see my screen? All good? Okay.
Yes.
Great. Okay, thanks. Yeah, so I will talk about sustainable energy. I'm not just luring you in to give you an environmental discussion. I'll show you how what we've been doing over the last, it's been a long time, 10, 15 years for sure, how we've looked at our environmental issues on the landscape and turn those into opportunities, such as the Sustainable Energy program that we've been involved with. So I'm first going to just touch on sort of what water retention and natural infrastructure is and how that actually connects to the work that we did with these energy projects. And then of course, talk about the cattail nutrient bioenergy project, why we got into it in the first place, and how that we were able to prove that you can generate these low carbon emissions, basically use this low carbon fuel and generate carbon offset credits that you can sell on the open market. And then of course, I'm going to talk about the Bioeconomy Atlas to show you how we did quite a bit of work on looking at biomass supply, and then of course the logistics of moving that biomass across the province and sort of what our current priorities are right now. So first of all, I want to just sort of introduce what is natural infrastructure. This may be the first time you've heard this term before. I'm guessing you know what infrastructure is, so gray infrastructure, anything you build, bridges, wastewater treatment plants, water retention areas that are made out of concrete, things like that. And then you have what you may have heard of as green infrastructure. So this is everything to do with the biomass burners, the solar panels, geothermal, wind energy. And so these things are the green technology sides of infrastructure. And then of course we have what I mentioned already before is this what the term is a natural infrastructure. This is a new word that's gained a lot of attention over the last number of years, which we really enjoy because we've been working in the space for a long time. Before it was sort of called natural infrastructure. It's also called nature-based solutions. So it's essentially using the power of nature and things like wetlands and treed areas, and that creates this natural environmental infrastructure. And we can use that natural infrastructure to enhance the abilities and the function of our traditional infrastructure. So we're not saying one replaces the other or one's better than the other. They go hand in hand. And so first I just want to introduce the water retention as natural infrastructure. And this has to do with the reason why we got into it in the first place is really addressing these issues of flood management on the landscape. And this, especially what you see here is a wetland. It's an enhanced wetland. This is an area that we work in a lot, these types of systems, and this is natural infrastructure. This is using these natural systems like wetlands to provide these benefits. And it's not just for flood management. So that's really what we've been involved with a lot is we're not just using these systems to protect us from flooding. So I just want to introduce to you the Lake Winnipeg watershed issues. And this is really how we sort of got drawn into this area in the first place. And all of you who are on the prairies know and are very familiar with these issues. We have issues of flooding, typically in the spring. This spring we had nothing. But typically in the spring, we have concerns with flooding. We have flooding issues during storm events as well. And then, of course, with that water comes the washing off the landscape from wastewater. You get that nutrient loading. And in Lake Winnipeg, that issue is phosphorus. And so essentially, when you have too much phosphorus, you get issues like the algae blooms that creep up in Lake Winnipeg and wash up on the beaches. And so we wanted to look at ways that you could actually address these issues at the same time. And of course, climate change is another thing we hear a lot about. And that, as we see in these strange years, climate change, this changing climate is really making things a little more complicated. So water retention basically is what we're referring to as natural infrastructure. And then down at the bottom is just another sort of definition of natural infrastructure, just so you have it in your mind when I'm talking about it. It includes the wetlands. It also includes roadside ditches, if you want to believe that too. These are, you can consider these things linear wetlands. It's a critical part of our drainage infrastructure, and these are natural systems. These long roadside wetlands. And then we have grassed areas, treed areas. So these are all things that slow down water, slow down nutrients. And this natural infrastructure is also, if you're seeing where I'm going with this, it's also producing biomass. So we have these systems that grow a lot of plants, grow a lot of natural biomass, and this stuff can actually be harvested and used in these biomass systems. So first of all, I want to take another step back and just introduce wetlands. I always respect the fact that not a lot of people. There are people who may not necessarily be completely aware of the critical function of wetlands in the landscape. And you see these low-lying areas, including roadside ditches, and they're a critical part of our healthy watershed. They've been called nature's kidneys because of the function of these plants and how they naturally filter stuff. They store runoff water, they store nutrients. And so what we really try to show in our work is that you can manage these systems and really enhance these abilities. We're not talking about mowing down and destroying all the wetlands. We're talking about incorporating managed wetlands into our systems, and roadside ditches, it can be a managed wetland. They have all kinds of environmental benefits, but essentially now we need to understand them better. They need to be strategically located. If we're putting in water control structures, they need to be strategically managed at the same time too, which can include harvesting. So essentially, how did we get into this whole bioeconomy area? Well, as I mentioned already before about the issues of phosphorus, this is kind of how we got involved. Was we had very basic questions in 2005. Could we actually harvest things like cattails and other plants in these systems to capture the phosphorus, capture the contaminants that they're naturally taking out of the system? Could we harvest these systems as a part of management and remove that phosphorus? And then, of course, if we're harvesting all this biomass, what are we going to do with all this biomass? So again, a very simple question: could we actually use it as an energy source to replace fossil fuel energy? So using these low carbon biomass sources and gain greenhouse gas benefits and offset credits. But of course, the main thing, of course, is what markets and incentives would make this work. And so this was a big part of our program, was not only exploring these things, but also what would actually make these things work, and how would people actually view these things. So this is a real summarized version of many years of work, but this is essentially what it was. The early research stage was the fundamental questions: could we harvest cattail? Could we turn it into a sustainable fuel product? And could we burn it to produce heat energy? And yes to all these questions. We show that you could successfully harvest cattail. You could harvest a lot of it in a very short period of time. We were in fact taking phosphorus out of the system, which is of course was the most important question for us. And then we showed that you could turn it into many different energy products, which I'm gonna talk about. And it creates these low carbon bioenergy fuels. And of course, at the same time with all the management, we're showing that you really improve the wetland habitat and the biodiversity value. So you're getting all these benefits together: the remediation, the habitat renewable, and those reductions in greenhouse gas emissions, which are really, really important for us. We did a lot of testing on the energy value, where these were always the first questions, that you get when you're talking about using something as a fuel. Well, how much heat energy does it have? How does it compare to everything else? And we showed that these products, especially those compressed products, really had significant heating value. And this was really important to show. They had high yield, they had significant phosphorus content. And so we were really proving the fundamental questions that needed to be answered. And of course, we looked at timing of harvest. So not all biomass is equal. The seasons are not equal. We did a lot of testing of nutrient, energy value, things like that. And we really showed that fall was sort of the best time for harvesting for many reasons, actually. So summertime was more complicated. The material was wet. The cattail is about 80% moisture content. So it's really wet. These wetlands usually contain water. Wildlife are using these systems. And so if you wait until the fall time, these plants have really lost a lot of moisture. A lot of these systems dry out towards the fall time, and they still retain enough phosphorus to make it useful. The wildlife is migrating, and so you can get in there and harvest in the fall time. Winter is impossible. We attempted that many times. This winter may have been a good year to harvest. And then in the springtime is more challenging, of course, with flooding comes in. If you don't get it in early enough or at the wrong time, you have issues with flooding. And in the spring also, if you're harvesting for nutrient capture, those blue bars there, what they show is the amount of phosphorus in the biomass material itself. And so if you're harvesting from a phosphorus management perspective in the springtime, it's lost a lot of phosphorus. And so it's not a very good time to harvest from a nutrient management perspective. It's very good for energy because it's very dry, but you have to really be able to get in there and harvest. So now we wanted to take what we learned and we wanted to move it into an applied scale, because research is fine and it proves what we wanted to show, but can you actually do this in a realistic and at scale? So a lot of drivers and opportunities were happening at the time. There was a lot of funding for surface water management, so we were able to get funding for that. There was a real priority to reduce phosphorus loading, so we were getting funding for that as well. But the biggest thing, and a lot of you probably are well aware of this, is the market demand because of the ban on the use of coal that was brought in 2014. And by 2017, users had to be switched off of coal. And this was a huge driver for us because there was funding available. There were biomass energy programs in Manitoba. We had industries such as Manitoba Liquor and Lotteries that wanted to support locally produced carbon offsets. So they were a big funder for us. And there was habitat renewal projects. So we put all these funding pots together. We looked at a lot of these priorities, and we wanted to really show this at scale. And we wanted to prove that the markets were there. And so this brought us to Pelly's Lake. If you've heard me speak before, or if you've heard about Pelly's Lake, this was really the flagship project. It still is for us in the water retention world. This is one of the flagship retention sites in Manitoba, and where we really proved a lot of these harvesting and energy processes and methods. So where is Pelly's Lake? It's there down at the bottom in south central Manitoba by Holland, Manitoba. And this is from what it looks like from the air. Very straightforward system. It has a water control structure that was built that right in the middle there is the spillway. So in the springtime, it fills up like this. We have the spillway, so the water can flow. It doesn't go over its capacity. And then on the bottom right side there are the culverts, the gated culverts. So the system is closed. They hold back water in the springtime and to prevent flooding downstream. So again, it's not just for flood management. There's a whole pile of benefits that are active in these types of water retention projects. You have the flood control, you have water recharge later in the season, you have the phosphorus capture, the habitat renewable, but then you have that biomass crop that's growing there. And these systems like to be managed. The wetlands typically go through natural cycles of drawdown and flooding. That disturbance is healthy for these systems. So a site like Pelly's Lake, which was not managed on a regular basis, was really overgrown with excess biomass, excess debris. And so getting in there and doing that management is extremely beneficial for that system. So now this brings us to the fun stuff, the harvesting project. In springtime, this is what it looked like on the ground. So this is after our first year of harvest. There's some bales there that were left behind and sacrificed to the flooding. And so we realized pretty quickly that this site really fills up with water. So we have to make sure to store stuff far enough away. But our biggest concern, of course, after the first year of harvesting, you can see there's no standing debris there in some of these sections, was that all the cattail was going to die. And then that would be the end of our biomass crop. But luckily, cattail is extremely competitive, extremely resilient. And this is what it looked like in the summertime. Once the water draws down and cattail, it really takes off. And it's not just cattail in here, which is the exciting thing, is that through this habitat management is you get other plants coming in. So we went from a system that was thick with dead debris to a nice, vibrant green system such as this, and you have lots of mixed plants in there as well as cattail. So it really rejuvenates the system. And then, of course, this is what it looks like in the fall time. So we had some really good years. We had some really bad years. So some years it was too much water and we couldn't get in there. That's always the challenge when working in systems which you can't completely manage. So you can't always get rid of all the water. But also we were trying to prove that you could do this with conventional agricultural equipment. So that was our goal right from the beginning, was we didn't want this to be some strange project where you had to get all kinds of specialized equipment, you have to custom build stuff. We wanted off-the-shelf equipment, and that's exactly what we set out to do. So here you have off-the-shelf equipment. And this is what the habitat looks like after the management that I showed. So it's a beautiful shot of what the wetland looks like. And it looks, when you look at it from sort of the shore, it may look like it's thick and dense, but then if you get up close, you have these nice open patches where the wildlife really likes these open water patches. So the habitat restoration benefits would have been one of the goals previously by organizations such as Ducks Unlimited, these other groups. Just the habitat restoration alone was enough to do these types of systems. So we tried a lot of equipment over the years, but the best equipment that we used was the rotary disc mower, because it had the crimping rollers, and this is a piece of equipment that's used for forage, high moisture forage, and it really sped up the drying process for us. So we were able to use the rotary disc mower, lay down the swaths, let it dry. And if we had really good conditions, we could be baling with it within a week or two, because the crimping rollers, bites into the plant material and helps draw out that excess moisture. So it was a really perfect piece of equipment for us to use. Some other equipment we use when we were working in these roadside ditches is a piece of equipment like this that a lot of the RMs use. It's very slow, it's very labor intensive, but this is how they typically clean out ditches if they're steep sided ditches. The other picture showed there's actually one of the shots of us in a wider based roadside ditch. But essentially, just to show you that we were harvesting in both the retention projects and in these roadside ditches. And we did a lot of baling. So baling was the biggest sort of focus in the early years, between 2012 to 2015 for sure, up to 2017. And then we were kind of transitioning to try other things. So we tried some forage chopping, creates lots of loose, fluffy material, but it created these really cool cattail chips. But I'm mostly going to focus on the bales. So this is what we did a lot of. We created a lot of bales over the years. So the market back then was the solid fuel, and that kind of drove our sort of our project goals. It drove really the objectives of what we were doing, and it was that ban on the use of coal for space heating, which really drove up the demand to try something interesting. And of course, the largest users of coal were the Hutterite colonies, and so we worked with some great colonies to test the different biomass products. We were involved in some of the pellet production. And so it was a really fun time to be involved in the biomass industry for us, because we were able to try out some of these interesting products. And it sounds like it's still kind of the same, that there's biomass out there, But it's a little bit unorganized still, joining the users and the producers. So I'd like to be corrected on that. Maybe it's more organized. I don't know. We haven't been involved in the last few years, but at that time that was the challenge was there was biomass material available, but now we needed to process it because in a lot of cases people couldn't use it the way it was. We needed to bring the suppliers and the providers together, or the users together. So we were involved in some of these fuel pellet projects. We were able to supply our cattail biomass and make some really cool cattail fuel pellets. I've still got a number of these bags kicking around that I use. But we managed to make a really cool and really useful fuel pellet. Many different blends were tried, cattails and grasses, cattail and wood. Of course, we're helping out with some of the wood as well. But it was a blended fuel pellet that we were really most happy with. Sure, you could try to make a pure cattail pellet, but that's not really the point. There's much more wood residue available. There was much more wood being processed into fuel pellets. And so integrating the sort of the lower volume cattail biomass into the wood pellets was much more useful. It was up to about 70% wood to 30% cattail, sometimes 80% to 20% cattail. But we were making a really nice fuel pellet that was being used on the colonies. It was being used at Providence University College with some local landowners. And so we were able to show that these types of biomass sources can be made into a compressed fuel product and used at scale. So we wanted to try other things as well too. So the pellets were fine, but we're not a for-profit industry. We weren't trying to market a pellet. We weren't trying to say that cattail is the ultimate fuel pellet. If you have the right system, if you set up the right shredding system, drying system, if you could combine your systems to also have the dryer also drying some of your fuel, such as the cattail, that goes a long way. So with the proper setup, you could have a system to create cattail pellets or cattail briquettes or cubes or whatever. So we wanted to try out bale shredding because it's much more efficient. It's much less energy intensive, and for sure, the cattail, we shredded lots of cattail. We used it as just a shredded fuel source. But the challenge with something like cattails and its straw, things like that, is it's very light. There's a lot of volume there, and it needs to be mixed with heavier product. So you need, again, such as the blended fuel pellet, you need a blended fuel in your walking floor system. So you wouldn't want to put piles and piles of cattail in there. You want to be able to mix it again, wood chips with shredded cattail, and then that had the best success in getting it into your biomass system. So I already mentioned these stacked benefits, and this was really important for us because we weren't trying to make a fuel product necessarily. We were trying to show an end product for this biomass source from the watershed management activities. And this is still true today. We're involved in these watershed management activities, and we want to be able to show that there's extra benefits and extra value. There's the surface water management, there's the biodiversity and habitat management. And if you explore and look at other markets in other countries, there are actually payments and credits that are provided for these things. There's water quality credits, there's biodiversity and habitat credits, there's the carbon offset credits, and now we hear about Canada's carbon tax. So there are all these other ways that money and costs could be reduced with some of these systems, but that's a whole nother topic, talking about credits. So just to kind of to close this off is just to say that we did a lot of work in this area. We partnered with a lot of amazing people. We worked with people from the States. We still do. There's a lot of management activities happening around the Great Lakes and the upper the Midwest in the U.S. We've worked with in Europe and Germany, the Netherlands. There's lots of harvesting activities such as this that happen as well. So we've been involved with a lot of great organizations. We've co-authored many books, articles, things like that. And so we continue to do the water retention work. Now we're sort of refocusing our efforts to try to understand these systems a little more. So there's lots of systems being put in southern Manitoba, and we are working with the municipalities, the watershed districts, to try to understand them a little bit better. So I'm not going to touch on this at all, just to kind of sort of to show you that we didn't abandon the water retention work. We're still very much involved with that, and the success from Pelly's Lake has really advanced the water retention work in Manitoba. So just to leave you with this, we're involved in monitoring, modeling, all kinds of fun things. So if you want to learn more about our water retention work, by all means. So as I mentioned before, we wanted to first prove that you could do this with conventional equipment. But we didn't want to stop there. You know, we showed that yes, you can use conventional equipment. We've been using that up to now. We've been struggling with it a lot as well, because you have years that don't cooperate. But there is really customized equipment, specialized equipment that is readily available. It's widely used, but not in North America. So this is the kind of equipment that's used in Europe. There are several manufacturers that build these things, these tracked harvesters that are used for all kinds of wet agricultural activities. Our colleagues down in the US, they bought one a number of years ago. So they used it around the Great Lakes. They've used it in the upper Midwest for harvesting projects. And there's one that has been purchased for Manitoba. So that's a nugget of information out there that you can think about. But apparently there is one that will be operational here in Manitoba in the summer of 2021. So stay tuned for more fun stuff with a specialized tracked harvester. So what have we been doing now instead of energy? Well, we transitioned. We're still doing the watershed management and the harvesting work, but we've transitioned to what is known as green manure. So this is another buzzword that's used a lot. It's basically just putting your compost and organics back on your field. So what we've been looking at is using the material instead of the shredded stuff going to energy, using the shredded stuff or the foraged chopped cattail chips, using it for livestock bedding. And then of course the livestock use it, it gets soiled, goes into the manure and the old bedding pile, turns into compost. It eventually ends up back on the field. So for us, this is a really interesting story as well too, because it's that circular economy story. It's that cycle of you're taking the stuff out of these areas, the nutrients, the phosphorus, the organic material, the carbon, and instead of getting rid of it, you're putting it back on the field where it needs to be. You're improving soil health. You're improving the carbon storage. You're putting that carbon back into the ground. So it's a much more interesting story for us currently right now. And then so we've been focusing a lot of attention on that because of a lot of our partners are also working in agricultural soil health. And I just want to throw this in here too as another piece of information is renewable natural gas. So this is another thing that's been gaining a lot of attention, globally and in Canada. So there's been discussions in Canada now. There's more in Ontario. They have there's regulations now for on-farm renewable natural gas generation, and essentially it's this stuff that's being put into these anaerobic digesters. It's producing biogas, and then you can go through this whole system of cleaning the gas. And once you get it to a clean state, it's basically a substitute for natural gas. This comes from, you can capture landfill gases, you can have agricultural waste, you can have sewage sludge, all kinds of things can produce methane and then cleaned to produce this renewable natural gas. So this is something that's sort of been this pie in the sky project, but wouldn't it be really cool to do something like this locally? Take our harvested cattail, throw it into a digester and create renewable natural gas. That's kind of a pie in the sky. So now we'll leave off on the Bioeconomy Atlas. I won't be able to answer too many of your technical questions on this one because I wasn't involved in the creation of the atlas. I was involved in the project heavily, but not in the actual creation. Inside this Bioeconomy Atlas is a tremendous amount of programming strength. Like it is actually quite unbelievable what's gone into the creating this atlas. You know, running it on Amazon servers, running it, you know, GPU, memories, all that stuff. I can throw out the buzzwords, but I can't explain to you what it is. But essentially, what this atlas is, it's an inventory of biomass in Manitoba, combined with these very powerful models that look at the biomass harvesting, and on top of it is the logistics optimization model, which is, it could be used on its own outside of biomass. So I'm going to quickly just sort of run through what it is and why there was demand for it. Well, at the time, and this is a couple of years ago now, but there was considerable interest in Manitoba investment, and we didn't have the answers to industries and investment that, you know, were interested in potential, you know, biomass facilities, biomass energy, things like that. And so there was a real interest at the time to try to quantify how much biomass we actually have in the southern part of the province. And then of course, moving it, what's the cost? If you plunk a facility down, or you you put in a biomass boiler, what's the cost of moving material to this area? And it had to be credible, it had to create realistic simulations and be able to analyze risk. And that's what it does. So again, it's a whole pile of information piled on top of each other. We have many different spatial data sources. There's the information about sources of biomass. There's the agricultural crop inventories. There you can put in the demand sources, and then you can create all this whole network, and you can create this cost benefit analysis and the cost of moving biomass across your system. So this is one shot from, so these are sort of screenshots from the atlas, what the information that you can get from it. One of them is crop residues, and these are based off of the annual crop inventories, you know, what's on the land, and it's based off of, you know, understanding of how much residue is left from these crops. And this goes back, you know, many years. You can average many years of data to show where the densities of crop residue are across the province. Of course, every year it changes, and you want to be able to take that into account. We have forestry data in there as well. We have logging residue data. We have some sawmill data. So we have the forest and the wood byproduct data in there as well. So you can look at, you know, densities, harvesting densities, and you can also create the logistics of moving that material across the southern part of the province. And of course, for us, this is another layer, is looking at this. It's called marsh density here, but it's essentially these unconventional biomass sources. So you can look at you know, grasses across the landscape. You can look at if you know where your water retention projects are, you can analyze that. You can look at your roadside ditches and estimate biomass from the roadside ditches. You look at managed wetland systems, and so you get this again. You can get this inventory of what you would call unconventional biomass sources. So the other stuff that's on the landscape, and you can combine all these layers together. And there's a lot of stuff that happens in the background. You know, there's lots of inputs from costs, and there, you know, yields and farm areas, harvest schedules, the equipment that's used. You need to know the carbon emissions, the weather data that goes into there. And then you can get all kinds of outputs into this. Most importantly, the costs, the biomass, the energy that's used, the carbon emissions that are produced and that are saved. And then down at the bottom, my label seems to be missing there, but these are future outputs. We wanted to enhance this atlas to be able to look at phosphorus capture, water retention, the habitat value, the economics, and the cost benefits behind all of that stuff. So that's sort of future goals for the atlas is combining this other benefit data, this other cost benefit data. Because there's a tremendous amount of information in being able to cost and provide value to these environmental services. And the atlas creates things like this for you. It creates maps of transport costs, you know, GHG emissions, biomass densities, things like that. So the star is supposed to show a plant, and then it gives you a spider web of different information. So And that's about the extent of my technical knowledge of the atlas. So don't ask me any hard questions on the atlas, but I will definitely take down the questions for future discussion. Thanks.
Yeah, thank you, Richard.
Thanks, Richard. You went through an awful lot of stuff. Turning it over to Jack now for good luck with the questions, Jack.
Yeah.
Yeah, Richard, I was really fascinated by your biomass atlas. So just so I'm clear, that's a tool that ISD created and you own. Is it free to the public or to any entrepreneurs out there who are looking to maybe look at a business plan?
Definitely. So the how it's used right now is sort of on a case by case basis. We don't own it. So that was part of the project. Was it's a public resource. We had it openly available on the internet for a while, but the cost of keeping the Amazon servers running all the time was getting to be a little bit too much. And it wasn't being utilized on a constant basis. And so having the Amazon servers running all the time was a cost, was an ongoing cost. So now it's sort of in standby mode, and we can then fire it up when we have requests to use it or collaborate with it. So definitely it's being optimized so it doesn't use as much memory. It doesn't need as much power from the Amazon servers. So there is some enhancement that's hopefully going to happen again over this next year to make it more efficient as well.
Yeah, very, very interesting. Let's allow our two organizations to talk about that more. I'll get to some of the questions that have come in the Q&A, some good ones here. The first is from Jesse Mays. Is the harvest of biomass from natural systems regulated in any way?
That's an excellent point. And I tried to allude to that, but we're not in the business of mowing down natural wetlands, going out there and harvesting prairie potholes, these important critical systems. What we're more interested in is systems that are already being managed. So roadside ditches are, all intents and purposes, are wetlands in a lot of cases, and they have to be managed because of safety and the municipal regulations. So the material is typically mowed. Municipalities also burn them, herbiciding sometimes, which is, we won't talk about that. That's not something that we like. But essentially these systems need to be managed. And so we're really showing that you could harvest these systems and take that biomass out of the system to utilize the biomass, remove the phosphorus and the other contaminants, improve the ditch conveyance of water. Same thing with the water retention projects and also constructed wetlands. These things, they function so much better, and you can enhance the habitat and the biodiversity value by managing these systems properly, and you can really enhance the benefits. So again, it's systems that are meant to be managed. It's not looking at natural systems. Gotcha.
Yeah, which is an important distinction for sure. Yeah. So the next question is from Daniel Friesen. Large bale burners are common in the EU. Did you explore simply burning the whole bales?
We would absolutely love to, yes, but we have not. So if there's a bale burner, and again, not an old style bale burner. I grew up, I've seen the old bale burner style where it's chugging out smoke across the highway. Yes, we're very aware that there is bale burning technologies. I don't know if there's one in Manitoba. If there is, we'd love to try it out. But yes, for sure, that would be by far the easiest, cost-effective use for this material would be sticking it into a bale burning system for sure.
Yeah, well, maybe you and Cam should talk.
Yeah,
that would be really interesting. We have from an anonymous attendee. At one time, there was a biomass energy network called BEN that was being established. Do you know if that's still around? Is that an entity that you're aware of?
I was part of the BEN network. Yeah, and it kind of just sort of petered out. But I know that for a while there was still it was still unofficially there. People would, we'd get together a couple times. We met up for breakfast discussing biomass initiatives in Manitoba. So I'm not sure of the current state. It doesn't, as far as I know, it doesn't officially meet, but maybe I'm out of the loop and I don't know. But it would be actually really beneficial again to start something like that up again. We had a lot, and it's probably a lot of people on the webinar today who have been involved in the biomass industry for a long time, and we had some really productive years there. You know, when we were involved from about 2012 to 2017, the biomass industry was booming in Manitoba. It would be nice to get that momentum back. So yeah.
Jack, if I could just interject for a second, Daniel asked another question earlier on. He asked, have you heard of the www.biomassbrokerage.com? And I don't know anything about that, but I'd be curious if anybody is aware of it, whether it still exists or if they can shed any light on that.
Yeah, I don't know. I haven't checked it out in a long time. Yeah, that was Bruce Duggins was involved with that, the brokerage. Yeah, I honestly have not looked for it. Everything survives on the internet somewhere, so it might be out there somewhere. So.
Okay.
Next question is a little bit related to one of the earlier ones you alluded to on the regulatory. The anaerobic digester project that tried to get off the ground in Manitoba seemed to run up against some significant regulatory challenges. Other jurisdictions seem to be able to make these work. Does anyone have suggestions on how we can work through those challenges? I guess just overall on the regulatory side, you know, if there's some entrepreneurs or some startup companies that are thinking about getting involved, I know my office sometimes has taken calls from you know, some pretty enthusiastic entrepreneurs that are on the biomass front. You know, what would be the challenges and what sort of things can they do to navigate those challenges? Yeah,
that's another excellent question too. And I don't know, you know, regulation was definitely part of that project, but also technology has really advanced over the last decade. You know, since that project, it's not quite a decade, but the biogas technologies have really advanced, especially for cold climate systems. And there's quite a few of them now in Ontario, Quebec. Actually, in you know, almost every province I think has some activity except Manitoba. I'm part of the Canadian Biogas Association. Very interesting organization. There's a lot of momentum with biogas across Canada, and it's actually quite interesting, the technologies that are being used. So yeah, the question was always, can it be done in Manitoba? And there's a lot of skepticism it can't be done in Manitoba, but apparently it can. You just need the right technologies. So I don't know enough about it. I'm just really interested in it. It would be really neat to have something like that happen in the prairies, where we could try out some of these biomass sources. Landfill gas capture is extremely common, you know, and Brady landfill is from what I know, from what I've heard, is that it's meant to do that eventually. So they're capturing the landfill gas and flaring it right now to convert it from methane to carbon dioxide, which is better. But I think it's actually the long-term plan was to eventually they could capture that gas and utilize it. So that's sort of the easiest low-hanging fruit to really reduce greenhouse gas emissions in Manitoba, would be to have Brady landfill actually, you know, convert that gas for a reusable natural gas.
Yeah, I seem to recall University of Manitoba looking at possibly tapping into that Brady landfill gas storage that they have there. So next question is from Blair Skinner.
Excuse me, Jack, if I could just interrupt for a second.
Sure.
We're a little bit past 8:30, and I certainly don't want to cut off the questions at all, but I just wanted to let people know that if they do have to go, if they did have a cutoff, that they needed to be gone by 8:30. Thanks for attending, and we'll carry on for another 15 minutes or so, if that's okay with everybody. And Cam, if you could turn your camera back on too, I think we'll have questions for both of you before we're done.
Yeah, and I'm good to keep going as long as our guests are up to it. But
yeah, sure.
The next question is from Blair Skinner, Mayor of local government district of, sorry, it's cut off on my screen. The Penny Lake experiment result in significant phosphorus being removed from the water system?
Sorry, can you repeat that again?
Yeah, this person's asking about some quantitative data on the removal of phosphorus from the water system on the Pelly's Lake experiment. So how much phosphorus was removed? Did that get studied?
Yeah, for sure. Shoot, and I can't, I don't have those numbers at the tip of my tongue, but there's different sources of phosphorus removal in the Pelly's Lake system. So we looked at the removal of the biomass itself. So the biomass is absorbing, is taking up phosphorus. You physically take it out of the system, and we quantified that. So the amount of biomass we remove, there's a quantity of phosphorus you're actually taking out. But then it's Pelly's Lake itself as a managed system that's what these wetlands do, is they also remove phosphorus. That's actually ongoing right now. It totally depends on the season. Like, it depends on the runoff. It depends on the amount of water. It depends on the amount of phosphorus that's coming into the system. But that's actually where we've gotten better now at the water quality monitoring part of it. So we've been monitoring other systems. We're partnered with some other folks, Lake Winnipeg Foundation being one of them, in trying to better understand and quantify the magnitude of phosphorus being removed in a system like Pelly's Lake. And it has to do with retention. If you can hold the water for a longer period of time, you have much higher removal of phosphorus. If these systems are designed to move water within a week or two, you're not getting a lot of benefit to remove phosphorus. You get some, but you don't get a lot. You need to hold that water for at least, a certain period of time to allow the phosphorus to settle, to turn it to sediment, to bind to the plants and things like that. So, yeah.
So just getting back to the I guess the economics or the business case part of it. You've certainly shown and proven, I guess, with this project ending in 2017 on the water retention, that it can be done. What sort of, are you aware of any startups or companies out there? I mean, the one that comes to mind recently is Taifa. I saw a presentation by them who are looking at harvesting cattails. Other than Taifa, is there other municipalities or businesses that have taken your research and run with it, or are just running it on their own with the information that they have?
Yeah. So we've been very fortunate to again, we're not a for-profit company, so we've never had the vision of taking it to the finish line, so to speak. But everything we do is to help drive policy change and policy recommendations. And so we've been, when we look back into what we've done, we've been very happy at the uptake of the stuff that we've done. So, not everything has worked, and not everything has turned into a revolutionary change. But there's been a lot of change, especially with the view of biomass, the view of climate change, the view of trying to reduce our carbon emissions. We have, some really good provincial programs now for wetland protection, for water retention. There's some really good funding programs through our trust programs to help fund watershed and landscape change and conservation. And so we're every step of the way to try to do that as well too. We helped in the conversion from coal to biomass. We tried to help as much as we could in easing the pain, I guess, of transitioning off of coal, showing alternatives, providing our support as well in the projects. The biomass industry has continued on. It didn't disappear, so it continued on. There are sort of end products that come and go, so we're always looking for the most interesting end use, which is why we're looking at livestock bedding right now and soil health, because that seems to be the demand in the market right now. So the landowners are looking for that material. They want to use it, so that's why we're focused our attention to that. And yeah, and the groups like Taifa, they've looked at it from the fiber perspective. So we didn't do any of that at all, but there's other companies in Europe who actually create OSB board from reeds and cattails and things. So these compressed strand board from things like cattails and reeds. And there's a whole pulp industry in China, millions of tons of reeds and cattails that are converted to pulp. it's always the local market. So I know that's not an answer to your question, but it's the local markets sort of drive everything that we do, and it's really encouraging to see a group like Taifa come up that has found a fiber use and an end use for something like cattails, which creates that could create that demand for harvesting of the material and creating it into a fiber, essentially a reusable shopping bag type product.
We've got a question here from Wayne Digby, and then I'm going to follow up with the final question, unless anyone else wants to put a question into the chat. But Wayne Digby has asked, what are the key issues that need to be addressed in order to encourage ag producers to seriously consider the utilization of biomass on their farms as an energy fuel? Are we looking at education, demonstrations? Any other thoughts on that?
I'll let Cam, you can take this one since you guys deal with more of the eggs fuel right now.
Right. First off, Richard, a really good presentation. And I wanted to thank you for the subtle product placement in some of those pictures. Really nice. And yes, we do need to talk about some of the byproducts that you produce. And certainly there's a collaboration that we could work with. Yes, absolutely. I think that we need to get the word out on the viability of biomass energies and how they can be used. And so we are a for-profit company, and that's on us. We need to get that education out there. We need to be a part of that. We want to work together with our governments to help them understand and look to them to help in that education. But I think as our farmers get to understand the values and the savings, farmers are notorious for having to work on really small margins and a lot of variables they can't control. And so I think that there's an audience there, and we just need to get them to be more aware of the benefits.
Yeah, good.
Yeah.
Thank you.
I would fully support that too. Education and that knowledge sharing. The knowledge is out there. We're not the first ones to think of trying to utilize these strange biomass sources for energy or fiber or bioproducts. We need to stop reinventing the wheel, and we spent enough time proving that you can create products out of these different things, whether it's cattail or straw or whatever. And it comes down to a lot of policy and funding opportunities and competing against things like cheap natural gas and electricity, and regulation, trying to bring trying to do something on farm, and hitting roadblocks every step of the way is not very productive. So
yeah, and I've just been hearing other things, people looking at researching water retention biomass, like duckweed, for example, is a potential biomass product that could be looked at. But I'm not even sure we've looked at all the opportunities out there. So ISD, you had this water retention project that ended in 2017. Then you moved on to the green manure, and that's, according to your chart there, ending up this year. Is the next step, you alluded to natural gas generation. Is that the next step for ISD? Is that what you might look to next if you're coming to an end with 2021 with the green manure project?
Who knows? That's kind of my pet project. Is I've been connected to the Canadian Biomass Association, and with the whole pandemic, really shut everything down. I was supposed to have attended a few conferences across Canada over the last year. There's a few of them. I attended some virtual ones, just try to stay up to date on some of these things. But I don't know. Some of my colleagues work very closely within that circular economy world, so that's a whole nother world. Plastics, circular, reducing plastic pollution is a big focus of the circular economy.
Right.
But these other things like biogas is right up there too. And the water retention work, we still continue to do that. That is one of our biggest priorities right now. Is we've just moved on from the energy side to looking at the monitoring and the modeling of those systems to try to understand them better. And the bedding is stuff that we're going to continue to do over this next year with soil health research into how the health of the soil changes. So who knows, biogas, it's there. Well, we'll see what happens with that one.
Well, I can't wait till we can all get into you know, a conference and we can have deeper conversations on all of this stuff, because yeah, I think the opportunities are coming, and as you mentioned, it was very in a few years ago, and I think it will be in again. So but the big pressure point for me right now is that my parkade, where parking closes at 9 o'clock, and I'll be sleeping in my office if I don't get out of here quick. But yeah, really good questions from everyone. You know, I know there was a lot more that came in for Cam, and by all means, you know, I know Cam's a very approachable person, and I'm sure you can reach out to Triple Green if you want. But with that, I'll pass it back to you, Randy, for closing.
Thanks, Jack. Great job on the moderating the questions. I had one point I wanted to come back to, and it was a question that came up at the end of Cam's presentation, and it was regarding the carbon neutrality question of how does burning biomass actually be, how could it be carbon neutral? I just wanted to make the point that, and this, I learned this back when I was doing some feasibility studies in my consulting work looking at biomass. It's mostly because of the fact that you're growing a new crop each year and you're burning the material from that crop. So the carbon came out of the ground to make the crop, and you're just recycling that carbon in a way back into the system, and it's kind of the circular situation that Richard alluded to, circular economy. So it is well-founded research that does support the argument that it's carbon neutral. There was just one other thing I wanted to ask Cam as well. You mentioned burning corn stover, and would most corn producers prefer to take the stover off each year, and if they could burn it to produce heat, or is it something they'd ever do every second year, or what would you think the situation would be there?
Yeah, so I mean, obviously, it's such a cost-effective alternative. So just from that perspective, for sure, they would. The stover is a hard plant or stalk to break down. And so if they can remove it and bale it and get it off of there, yes, great. I mean, right now, before this option was there, they would have to disc it and double disc it and break it down and try to enhance or speed up that breaking down period. So yes, there's a benefit to that.
Yeah, for sure. That's what I thought, but I just wanted to make sure I was on the right track there. Thank you both very much for your presentations, and even though Jack's gone, I'll certainly acknowledge him again as well. Great presentations, and we really appreciate you both taking part in tonight's event. I'd also like to thank Mia again as our supporting sponsor, and to acknowledge again our two platinum sponsors, Evolve Green and Golden West Communications, and our gold sponsors, Access Credit Union, Efficiency Manitoba, and PowerTech Solar. I'd be remiss if I didn't acknowledge Sarah, who's been busy in the background, making sure that the right slides came up at the right time, and everything worked out well. So thanks again, Sarah, for that. I'd like to remind everybody that our next session is 1 week from tonight, on April the 6th, starting at 7 o'clock again. And we'll examine some of the more futuristic developments related to powering the ag industry using sustainable and renewable energy. Think of electric tractors powered by electricity that's generated from biomass, those kinds of circular economy types of things. Jack Winram is going to join us for a longer period next week. He'll talk about some of the initiatives that Mia is undertaking to support and grow our green economy, and specifically to create and train people for the jobs of the future that will be involved in seeing that green economy grow. Last but not least, on the evening of April 6th, after the presentations that are occurring that evening, we'll also have our annual general meeting for Mancia. and we welcome you all to provide your input after hearing what we've been up to in 2019 and 2020. So thanks again, everybody, for attending, and Richard and Cam and Jack and Sarah for your wonderful job tonight. Thank you.
Thank you.
Thanks.